The trick or the important key in solving a trigonometric equation is to use the unit circle. We have to know the unit circle to solve the trigonometric equation. At the minimum, we need to know the special points and the special angle in the first quadrant. At the point 1, 0 and the point 0, 1, we should know that the angle associated with 1, 0 is 0 or 2 pi. The angle that associated with 0, 1 is pi over 2. Between 0 and pi over 2 is the angle pi over 4 with the coordinate root 2 over 2, root 2 over 2. If we take pi over 2 and divide it by 3, we will get pi over 6, and the coordinate at this point is root 3 over 2, 1/2. And using symmetry, the coordinate at the angle pi over 3 is 1/2, root 3 over 2. The trick is to count this as the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, the square root of 4 over 2. And going back, when y equals 0, we count this as the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2, which is 1. These are the special or nice angle on the unit circle. They are multiple of pi over 4 or pi over 6. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2, and so on. With this, using symmetry, we can obtain the angles in the second, in the third, and in the fourth quadrant. Sine of theta is positive in the first quadrant and the second quadrant. Cosine of theta is positive in the first quadrant and the fourth quadrant. Tangent of theta is positive in the first and the third quadrant. The trick that we use in this class is that all students take calculus. What this means is that in the first quadrant, all trigonometric functions are positive. In the second quadrant, only sine and its reciprocal is positive. In the third quadrant, only tangent and its reciprocal is positive. And in the fourth quadrant, only cosine and its reciprocal are positive. All students take calculus. Armed with this, every time we solve cosine of theta equal to a number, we simply draw the unit circle, and if that c is positive, we will draw a vertical line in the first or the fourth quadrant, x equals c, because on the unit circle, cosine of theta is defined to be the x coordinate. If c is negative, then we will simply draw a vertical line in the second or the fourth quadrant. This is x equals negative c. If we solve an equation where we simplify to sine of theta equals c, then we would draw the horizontal lines instead. If c is positive, we would draw a horizontal line that are parallel to the x-axis in the first and the second quadrant. This line is y equals c. If c is negative, we would draw the parallel line to the x-axis in the third and the fourth quadrant. This is y equals negative c. And lastly, if we solve an equation that involves tangent of theta equals c, then we would draw the line that goes through the origin. If the slope or c is positive, we would draw the line that is upward and go through the origin. If tangent is negative, we will draw the line that is downward that go through the origin. The reason why we want to do this is because we want to find all solutions. For example, if cosine of theta equals c positive, then we know that there are two main or initial solutions in the third and the fourth quadrant. If cosine of theta is negative, then we know that there are two solutions in the second and the third quadrant, unless when c is -1 in this case, because cosine of theta equals -1 only when theta is negative pi. Similarly, with cosine of theta equals c, if c is positive and it is not 1, then we know that there are two main solutions here. If c is negative, then there are two solutions, one in the third and one in the fourth quadrant. If tangent is positive, then the initial solutions are in the first and the fourth quadrant. But keep in mind that for cosine and sine, the period is 2 pi. For tangent, the period is only 1 pi. So with sine and cosine, we might need to find the two initial solution and add or subtract 2 pi from each. For tangent, we only need to know the initial solution and add pi to it to get to the next solution, regardless of which quadrant it is. If the solution is in the second quadrant, we add pi to get to another solution in the fourth quadrant.